So I have a pronghorn antelope that's accelerating from rest in a straight line with a constant acceleration of 1.7 meters per second per second. How long does it take for the antelope with this acceleration to reach up to a speed of 22 meters per second? First thing I want to do is I want to keep track of everything I know. I have an acceleration, okay? Acceleration of 1.7 meters per second per second. Now, when we're looking at acceleration, the units for acceleration are obviously meters per second, but there are other ways in which it can be expressed. For an example, it's not uncommon to see it being expressed this way, or even to be expressed, the IB way, which is this way. Okay, any one of those is going to be acceptable. My personal favorite is this meters per second, but as I was saying, if it's an IB class, obviously this is the way they expect to see it expressed. Okay, so acceleration of 1.7 meters per second. I have a velocity of 22 meters per second. Okay, and I have an antelope that's going to, here's my antelope, that's going to accelerate up to 22 meters per second. Okay, cool. Now, what I'm looking for is I'm looking for the amount of time that it takes to get it to that speed. Now, my acceleration, the definition of my acceleration, or the equation, I guess is the best way to put it, but it's simply the definition. Acceleration is equal to the change in velocity over the change in time. And this is what I'm looking for. Okay? So, what I'm going to do is I'm going to move this over to the other side, and I'm going to move the acceleration over using cross multiplication. That leads me to t, or delta t, which is just basically t in this problem, is equal to delta v over a. Now, delta v is the change in velocity, and the way that that's expressed is going to be v final minus v initial. And I've got a problem here because I only have one velocity. I have to determine whether that's a final velocity, initial velocity, or whatever, and I have to find out the other velocity. So I'm going to reread the problem and see if there's a little bit of information that I haven't recorded. So, if a pronghorn antelope accelerates from rest in a straight line with a constant acceleration of 1.7 meters per second, how long does it take for it to reach a speed of 22 meters per second? Well, it's right there, the word rest. If you're at rest, you're motionless. So when we hear the word rest, we hear 0 meters per second. Now we have a velocity of that. Now we have to determine whether that's the initial velocity or the final velocity. Well, it says it starts from rest. It accelerates from rest, so it starts off at rest and then gets up to 22 meters per second, or 22 meters per second. Sorry, 22 meters per second, not second per second. So the 22 then has to be my final, and the 0 has to be my initial. Well, the math on that's pretty simple. All I'm going to have is 22 meters per second minus 0 meters per second, and I'm left with 22. So just taking a shortcut, and I'm going to go over there and I'm going to write that out again. Okay, erase this really quick. So I said that the acceleration is equal to delta v over delta t. I did a little cross multiplication and I ended up with delta t is equal to delta v over a, which then I substituted in for here, and I said, well, delta t is equal to v final minus v initial all over a. And then now I'm starting to plug in numbers. I've gotten all the way to the point where I've moved every term around, I've expanded out my equations. Now I get to the point where I plug in numbers. I really don't want to start plugging in numbers in the very beginning. I'd rather do them at the very end. So V final, as we said, the analog gets up to this speed. So that's its final velocity. So delta t is equal to 22 meters per second minus 0 meters per second, because remember it starts at rest, over 1.7 meters per second. Now mathematically, oh, look at that, I just wrote right off the edge of the board. I'm going to erase this and read. So I had 22 meters per second minus 0 meters per second over 1.7 meters per second. Now, I'm not going to do the math. You can see that this term goes away. But what I am going to do is I am going to look at the units. If I have a meters per second over a meters per second, hopefully you can see that this and this cancel off. And I'm left with a per second on the denominator. It just means it flips. So my t is going to be 22 over 1.7 seconds. Okay, that per second dividing by a per second just flips that term. Okay, so that is my answer.